Okay, and we're back. This lecture, I'm going to go through the C05 shaders example project in the class repository. Let me kind of zoom in here a little bit. Just to kind of show you, this is pretty similar to what we had before, right? This is the previous example, the shader compiler. But this new one, you'll notice, is going to be a little bit more interesting. We now have these cool colors that are being interpolated, and you can kind of see a little bit of what OpenGL and the GPU can do for you, where they can make these colors really go from from red to blue without having to figure out all of the different colors in between. Cool. So let's dive into it. So let's start off and look at the folder structure here. We got a main.cpp, and like before, we have our app class and the safe delete function that's deleting it at the end. Really, we're just running the app, and we're calling it shaders. And if we run it, you'll notice that the name of the window there is shaders, which is what we expect. And let's open up the, and like before, we have our shader compiler code, which I believe we went over in a previous class, in a previous lecture. But this ultimately is reading shaders off of the hard drive, right? It's reading your vertex shader, fragment shader, and then setting up that program, and then gives you back the shader program as an ID value. So a nice little convenience function. And so let's see what's different. Let's actually open up the app class.h. And first thing you'll notice is the inclusion of GLM per the lectures that we had this week on GLM. GLM is a header-only library. You can kind of see, for example, I'm going to open up glm.hpp here, and you can see it includes vector 2, 3. Let's take a look at vector 3 just for kicks. All right. So you've got this template-based vector 3, and you can kind of do a lot of cool things with it, which is fun. Let's take a look at the code. Right. Type vector1 inl. INL. This is sort of a hacky way to include. So templates are really finicky when it comes to C++. If anybody who's used them, they can only be header based. You can't compile them. You can't put this stuff, and you'll notice down here, include type vector3 inl, which is this bullshit name of a file. It's really just the header file continued. It's just a good way to continue that splitting off of headers and implementation with a header file. But whatever. So you don't have to know much about that. We look down, we see our window name, our SFML window, all this stuff we have set up in previous examples. You should know, kind of understand that by now. Here's a new thing though. GLM vector3 mv3 color, and it's calling a vector3 -1, which means if you're interested, this just allows you to instantiate a vector with all the values are going to be equal to -1. Is this big enough? Let me zoom in a bit more for people. Cool. Great. So what's different? Because a lot of this looks kind of exactly the same as before, right? If we look at the comparable, this is our app class from before. The only thing that's missing is really that color thing and GLM. So let's go into the app class.cpp and see what's new here. Let's make sure we don't have an old one open. Let me just make sure I'm opening the right one so I'm not all confused. App class. Great. So we've got our up here. This is just creating our app. And in the same way, this is the copy constructor that is private, and this is the copy assignment constructor, which is also private, and here's our destructor. Great. And we run, we initialize, we set the background color, and we run, and everything's the same, and we hit display every frame. So all this is the same. So let's take a look at display. And we'll notice that this is also kind of the same, except for one key difference, which is here's this GL get uniform location. And if you guys remember, we talked about this in class, in the lecture. So let's kind of quickly take a look at our shaders here. Notice we've got load shaders, basic color.vs, basic color.fs. Where are those? They're not in here, they're on our file system. If you recall in a previous one, let's go to my development folder, and we're in include simplex shaders. And let's open up this basic color vector shader. Here. And you can see this is just like that shader in the lecture slides. We have this out color v3 color. What is that? That was from before, we had that before. And then let's open up the fragment shader. And now you'll notice this uniform here, solid color. And what we're doing, so up here, we are binding everything, right? We're setting up our VAO, our VBO, we're binding to the VAO, and then we set up our buffer, and we enable our vertex attribute, and then we set up the GL attribute, and here's the color attribute. We enable these, right? And then down here, the big difference is we've got our solid color, which is basically a uniform, and that's defined here, uniform vector 3 solid color. So I will point out that here we do have now two vertex attributes. Let me kind of pull up an old one. You can kind of see how that's a little bit different than what was before. So here's our SFML example from back in the day, right? And notice here we have our get attribute location, enable attribute array, and then GL attribute pointer, and we do this code like that. But here it's a bit different. We in GL enable vertex attribute array. Notice here we enable the vertex attribute array after we get the position from get attribute location. But we don't have to do that here. And why don't we have to do that? I think this is a very, very important point that often gets looked over as an oversight. So we know that this attribute array is at location 0. Why? It's because of this vertex shader putting it, the position is in location 0, the color is in location 1. So here we're saying, okay, this is like the color, and it's going here. And here this is the, this is the position, and it's going to be at the 0. And here this is going to be the color. And so this is really kind of gets into this funky function. We talked a lot about this earlier in the class. GL vertex attribute pointer is telling me that my vertex data has a particular kind of structure. And you can start to see how the structure actually works. We have two attributes, so the attribute count is going to, the size of this thing is going to be GLM vector 3 times 2. And then we're going to pass in at 0, that's our first one. And it's going to be 3 floats. And then our second attribute, which is at location 1, then goes through the same thing. Notice this would also work if we tried to get the position, through the GL shader and so on. So we could even do, let me open this back up again. we could do, this would work as well. Or say I do, I'm not going to actually do this. Vertex attrib array, right, you can see that. So we can do that instead. By looking at now notice we would need the equivalent program ID, which is in our member variable. But this is equivalent. But we don't need to do this. Let's do 0. It's a particularly useful trick in when you don't necessarily know the structure of things, and if you have a complex structure or you want to pass to it a really convoluted vertex array. Maybe at the end, like I can show you guys, for example, what my code looks like for this stuff. It gets really nasty. So the other bit about this I really want to bring up is that you've got this piece here at the end. If you recall, if you look at the definition of this, the last bit, you've got stride and you've got pointer. What does that mean? So we have index of 1, right? That's our index. We've got the size of 3, so it's 3 GL floats, and the next bit is what is the type, and then the normalized, it's false, it's not normalized, and then we have the stride, and the stride represents how big, how is this contiguous memory going to be treated, if it's the size of 3 floats, or if it's 6 floats in this case, so we have to tell it that. And then this pointer, that tells this line where to look in that memory. So within that stride, this next attribute in the vertex shader is going to be found after a vector 3. So it's going to be the second vector 3. I know this is pretty wacky, so I really encourage you guys to play with it and try this code I wrote and see what happens when it breaks. Because if you understand this, like this is at the core of connecting to the GPU to the CPU, and I think it's really important. Like usually you don't do this attribute count 2, you'll define, in fact, why don't I just do that? Why don't I just open a project. Here, let's do this. Hopefully this works. It's not in this wacky state. This is some of my code, but let's open up OGL object, or OGL sphere, I think. Right. You'll notice here, this is when I initialize my object, and you can kind of see, like, you end up using almost every single aspect of this thing, and you don't even have to have, the structure. You just create this underlying object, which is a vertex, and you define it this way, right? It gets quite complicated in the things that you can do. It's pretty powerful. And really understanding how all of that works is really, really fun. So I recommend you guys really trying to play with this. Whoops. That was not on purpose. Great. I really encourage you guys playing with that, messing around, kind of seeing what makes it tick. because that's going to help you understand, I think, a lot of how to really work with this stuff in the future. Great. Okay, so back to this. So now you understand a little bit more about how these get connected, and also you understand a little bit better about how the solid color is connected. And then finally, what's nice about uniforms is you don't have to have them part of your VAO, right? They're just on their own. They're just uniforms. They just exist. And so all you need is a location, and you need to write to that location. If you try to write to a location that's the wrong type, you're going to get some memory stuff, things are going to blow up. So it's on you, or it's on your system to keep track of what's what. And I think that's another bit, like with OpenGL, you really can't shoot yourself in the foot. And so the big thing that we're showing here is if we don't set a color, let's look at the shader. If the solid color is not equal to whatever, then it's going to use the color that's in here, that's passed by way of the attribute count. Like, where are we setting our buffer data? Right here, our vertex. So we're pushing back the color here. So it's going to use this as a default color. However, if the solid color is not is set to non-1, then it's going to use that. You can kind of see here in process keyboard, and this is new as well. In process keyboard, if we press a key, the number 1, 2, or 3, or 4, if we press the number 1, it's going to set the solid color, this MV color, right? That's what it's using for solid color, to red, or green, or blue. Or if you hit the number 0, it's going to go back to -1, which then will go back to the normal triangle. So let's just try it, right? Let's run it again, now that we know what's going on. And so you can see right now, the way it's working is the fragment is being output is going to be the color passed in through the vertex. So you can see how the fragment shader is interpolating red to blue to green. But then if I hit a number, the number 1, now solid color is set, and it hits that conditional in the shader. To prove to you that this is working, I could even, make this, right, do something like, or something. And now if I run it, it will not do that because we went through this, it didn't copy the code, we have to change it. We have to change it in the binary. So now if I run it, right, actually it's probably a good thing to point out what just happened. So I tried to run it, and you see there's some issue here, and the fragment is telling me too much data in type constructor, syntax error unexpected, blah blah, like whatever, at 16. So let's see, line 16, it's right there, and it expected, it didn't get what it expected, right? So let's do this. I'm not sure why that happened, but that's fine. We're using an older version of GLSL 3.30. Okay. Oh, well, that's because I forgot to close a parentheses is why it happened. And now hopefully you'll see that the that now when I hit any number, it will not go to the solid. It will go to that weird color I chose, you know. So yeah, and then if I go back, it's not going to go to the component wise, and it's going to pull that uniform in through. I want to point out something to you guys that I think is extremely important. What happens if I comment this out? What will happen? Before I go to do this, just think really quickly. So we're setting the solid color. If I hit a number, what will happen? Nothing will happen. Okay. Cool. Let's do another game. Let's play one more game. This one, I think, is a bit more insidious. What happens if I set the color to just be 1? So I'm no longer using this color here. What will happen? Okay, I guess it's an older version of OpenGL, because that shouldn't have worked. Let's do this really quickly, just to prove my point, I think. No. Well, really it shouldn't work. Generally speaking, what happens is OpenGL will often, we might be having, we're hitting probably an OpenGL error and it's not being brought up to the top. But OpenGL will basically optimize out code paths that no longer do anything, and sometimes it'll throw out variables that are no longer being used. So in this case, solid color is not being used. In this case, color is not being used either. And it'll optimize out a lot of those code paths. And sometimes you'll hit these compile errors, or you'll try to set a variable that doesn't exist, and it'll complain. But I think you do need to use getLastError from OpenGL to get that, and this is not catching that error underneath. So just keep that in mind. I guess it's not easy for me to reproduce that issue, but you'll probably see it in later examples. So yeah, that's kind of just covering the shaders example. Here we're loading a shader from disk. We are setting multiple vertex attributes, and we're also setting a uniform. And so we're starting to actually really communicate with the other side, with the GPU side. For example, what if we did this? Let me kind of show you guys a fun example. Let me put things back to normal. What if we, instead of using the key stuff, we can go and take the mv3 color dot red plus equal to rand I'm not going to use rand max. And then we'll do this only for red. And then we need to I always forget this code. Sorry. There we go, sran. So we're doing that. Right. Of course, I broke my shader. I should fix it in the actual place that it is, which is here. Okay, so what will happen now? Well, it'll take a while because it started at -1. So we should probably first make this, get this to be MV3 color. Let's set it to one of these. Let's keep that functionality. So we're going to hit one of the values. You'll notice now that very little is changing. Oh, that's right, because we changed that code to not do the thing we wanted it to do. Sorry about that. That's confusing. Okay, I'm going to go here. I'm going to go back here and yes, yes. Okay, there. Now it's going to hopefully work. When I do this, in theory, it should change things. Oh, I see. That's because when it's equal to 1, it's going to go to 0, which we don't want. Great. But we also want it to increase by rand. What is rand max? Oh, and this is a very classic example of a stupid floating point casting issue. Okay. Cool. Now you can see it's doing a strobe light. It's going to go into black a lot. So if we do this for all RG, G, B, B, and let's slow it down just like by right, so we can see what the hell's going on. It'll do some funny business, which is pretty cool. So this shows you how you could, in theory, use the uniform in kind of a dynamic way. Now, one of the things I want to point out is if you were to want to do this on the vertex data, you could. But to do that on the vertex data, notice we're loading the buffer here. GL buffer data. You have to bind the buffer in the VAO, and you have to set all those values. And there's a lot of work to do that. That requires a lot of time, whereas the uniform is a lot faster. And so you'll find that, generally speaking, vertex colors are usually used for kind of underlying model information. And then you use a material on top of that, such as a color, and so on, which hopefully explains kind of that separation between material and color in programming of graphics applications. Cool, so that's covering the shader stuff. I will kind of move on with this particular example and show you how to apply some of the translations just in this sort of code level before we go into sort of future examples. So yeah, I'm going to stop this lecture here and then kick a new one off based on that.